Welcome back, my dear children. Good morning to all. In class 6, we are discussing the chapter Physical Quantities and Measurement. Today we are going to discuss from this chapter an important topic, measurement of mass by different devices. All those who have the book, please take out a book. Others, please stay on video and watch the video carefully. Okay students, yesterday we have wind up the class by this topic, devices for measuring mass. For measuring the mass of a body, we generally use two devices. First one it was, yesterday I told you, beam balance, second one electronic balance. Two devices we are using to measure the mass of a body. Those are the beam balance and the electronic balance. First of all, we are going to discuss about use of a beam balance to measure the mass of a body. Okay students? In this figure, you can see the beam balance. Okay, this is a beam balance. You observe it. Beam balance have one pointer here, and this is a beam, and this is right pan, this is left pan. Pointer. One beam is there, this one is a beam, okay, then this is right palm and this is left palm, okay. This is a basic beam balance. Okay students, now we have already seen the diagram of a beam balance, which is most commonly used. It consists of a straight beam of wood that can be made by metal also, okay. That beam I told you, I have shown you that beam can be made by metal also. Its length around 50 centimeter. Its length around 50 centimeter. The beam has a support just at its middle having a pointer. Two identical pans are suspended at the ends of the beam by means of strings of equal lengths. You can see once again the diagram here. Pointer, beam, left pan, right pan, everything you can see. Okay. Each pan is at the same horizontal distance from the support. Each pan is at the same horizontal distance from the support. That is, the length of beam of each pan from the support is equal. The length of beam of each pan from the support, that is equal. The balance can be held up by the support. The balance can be held up by the support. To measure the mass of an object, what to do? We are using standard weights. The diagram of standard weights are here. You can observe it. 1 kg, 2 kg, 5 kg, 10 kg, 20 kg. Usually we are using these standard weights to measure the mass. Okay. So to measure the mass of an object, we are using some standard units. It's already shown to you. Okay. However, smaller units also there. Those are like 500 gram, 200 gram, 100 gram, 50 gram, 20 gram, 10 gram, 5 gram, like that. Okay. Smaller units also available. Okay students. For measuring the beam balance is first held up. For measuring the beam balance is first held up. On holding up the balance, it is ensured that when there is nothing on either pan, the beam is horizontal. So, you have to see whether there is something in the both pans, right pan and left pan. Two pans are there. You have to verify that whether something is there or not. And also you have to verify whether the beam is horizontal or not. Sometimes the beam can be slant position in one side or another side. So that you have to be checked. The body whose mass is to be measured is placed on the left pan. The body which we want to weigh, that should be placed on the left pan. Okay, students, left pan. Then the standard weights are placed on the right pan. The standard weights are placed on the right pan. Okay, students, right pan. They are also adjusted that the beam is again horizontal on holding balance up. Okay, they are also adjusted that the beam is again horizontal on holding the balance up. The total of the standard weights gives the mass of the given body. The standard, how much weight we are keeping, how much standard weight we are keeping in the right pan, that will be given the mass of the given body. Okay. Now here is one interesting fact. Do you know, some shopkeepers use the grocer's balance shown in figure 2.9. This is figure 2.9. Maybe you have seen the grocer's shop like this, grocer's balance, okay, for measurement of the mass of objects like vegetables, pulses, rice, sugar, salt, etc. And also a goldsmith requires an accurate and sensitive balance. So he uses a physical balance. This balance is also used in the laboratory. In the goldsmiths and laboratory workers and laboratory also we are using a physical balance like this. Okay, grocer's shop we can see like this balance, grocer's balance, and in laboratory and with the goldsmith jewelry and all we can say like this physical balance. Okay, so three types of balance we have seen. One is this one, physical balance, then this is grocer's balance, and another one or first one here it is a beam balance. Okay, students, these three are very important. You have to learn about these three things. You should know what is the difference between these three. Now we are going to discuss about use of electronic balance to measure the mass of an object. Nowadays, for the precise and accurate measurement of mass of an object, an electronic balance is used. And electronic balance is used. Electronic balance is used nowadays. They are available to measure a small mass of 1 mg as well as a large mass of the order of a quintal. This electronic balance can be measured smaller units as well as the bigger units. Examples 1 milligram and also quintal also can be measured by the electronic balance. Small electronic balances are portable while big electronic balances are fixed at a place. Small electronic balances are portable. It can be carried from one place to another, but big electronic balances are fixed at a place. In figure 2.11 we can see a simple electronic balance. Okay, students, here this is an electronic balance. Okay, maybe you have seen the jewelry itself. Okay. Okay, students, an electronic balance has the following three parts. The structure, three parts are there. The structure, first one, structure. It is the load bearing part which transfers the load of the object to the load cell. Second one, load cell. It converts the load into electrical signals. The use of load cell is to convert the load or force into electrical signals. Another one part, third one part, that is the signal conditioner. The signal conditioner. It is the electronic part which processes the electrical signal and displays the mass. It is the electronic part which processes the electrical signal and displays the mass. So, these are the three parts of the electrical balance. Okay, these are the three parts. First one, the structure, the load cell and the signal conditioner. Okay, students, clear? Once again we can see the diagram of electronic balance. You just observe it. Okay, clear? Electronic balances measure the mass automatically without any prior setting or using a separate weight box. We don't want a separate weight box for the electronic balance. They directly measure the mass of the object. They directly measures the mass of the object. Just we have to keep the object on it. That's our duty. They directly measure the mass of the object and display it in the digital form on the screen. Clear? They directly measure the mass of the object and also it displays the correct weight on the screen. Okay. So, it is very easy and it is very useful nowadays. Okay, now our new topic is measurement of time. Measurement of time. The interval between two instances or events is called a time. What is the difference? Definition of time? The interval between two instances or events is called a time. We measure time in terms of the mean solar day. We measure time in terms of mean solar day. A solar day is the time taken by the earth to complete one rotation about its own axis. What is the definition of a solar day? A solar day is the time taken by the earth to complete one rotation about its own axis. Okay. The mean of 365 solar days in a year is called the mean solar day. What is mean solar day? The mean of 365 solar days in a year is called the mean solar day. Mean solar day. You understood now? The mean of 365 solar days in a year is called the mean solar day. Okay. Now we are going to discuss about the units of time. The SI unit of time is second. The SI unit of time is second. In short form, we can write second as S. The short form of the second, the SI unit second, that is S. 1 second is defined as 1 upon 86,400 part of a mean solar day. Okay. 1 second is defined as 1 upon 86,400 part of a mean solar day. Mean solar day we have defined early, just now. So, we can write here 1 second is equal to 1 upon 86,400 into 1 mean solar day. Please mark it. What is 1 second? 1 second is equal to 1 upon 86,400 into 1 mean solar day. Okay, students, if you look at the pendulum of a old clock, maybe you have seen the old clock, okay, old clock, you know very well. Just observe the pendulum of a old clock. The pendulum moves from one extreme to the other extreme in 1 second. In 1 second, the pendulum moves from one extreme to another extreme, like this, okay? Like this it moves. Thus, 1 second is the time interval between two consecutive ticks that we hear from a pendulum or clock. You can hear the tick sound from the pendulum. So, we can assume that 1 second is the time interval between two consecutive ticks that we hear from a pendulum or clock. Okay. And here it is one point, important point. In MKS or metric system, MKS or metric system, FPS system as well as in CGS system, the unit of time is S only, symbol S, that is second. In MKS or metric system, FPS system as well as in CGS system, the symbol of time second. The unit of time is second and also its symbol is S. The second is a smaller unit of time. The second is a smaller unit of time. Okay, you underline it, please underline it. The second, that is a smaller unit of time. Second is a smaller unit of time. A bigger unit of time is a minute. A bigger unit of time is minute. Symbol is MIN. Okay, MIN. The symbol is MIN. Minute. 60 seconds make 60 seconds. That make 1 minute. We know that very well. We know that this point very well. Okay, we are familiar. Then once again we can discuss. So here we will get the point. 1 minute is equal to 60 seconds or 1 MIN is equal to 60 S. MIN, that is the symbol of the minute. That is the symbol of minute. MIN. So we can write here 1 MIN, 1 minute is equal to 60 S, 60 second. A still bigger unit of time is hour. Bigger unit of time is hour. The symbol is H. The symbol of hour, that is H. 60 minutes make 1 hour. 60 minutes make 1 hour. So we can write here, once again we are getting one more point here. 1 hour is equal to 60 minutes or 1 H is equal to 60 MIN, minute. 1 hour, 1 H is equal to 60 min. Okay, min, MIN, that is the symbol of minute. H is the symbol of hour. Thus 1 hour is equal to 60 minutes. 1 hour is equal to 60 minutes. Then how many seconds it is 1 hour? 60 into 60 seconds, that is equal to 3600 seconds. Okay students, you are understanding now? 1 hour is equal to 60 minutes, that is equal to 60 into 60 seconds, that is equal to 3600 seconds. 1 hour is equal to 3600 seconds. Another bigger unit of time is a day. A day is another bigger unit of time. 24 hour make a 1 day. 1 day makes 24 hours. 1 day is the time taken by the earth to rotate once on its own axis. 1 day is the time taken by the earth to rotate once on its own axis. To rotate once on its own axis. How much time is taken by earth? That is called 1 day. Okay. And also we can write now 1 day is equal to 24 hours. Then how many minutes are 1 day? How many minutes we can have in 1 day? That can be find out by multiplying 24 hour into 60 minutes. 1 hour is equal to 60 minutes. That's why 24 hour into 60 minutes is equal to will give the minutes. How many minutes contained in a day? Okay. Then how many seconds? That can be found out by 24 into 60 into 60 seconds, that is equal to 86,400 seconds. Okay, students, one day is equal to 1440 minutes and one day is equal to 86,400 seconds. A year is another bigger unit of time. 365 days make 1 year. 1 year is the time taken by the earth to complete one revolution around the sun. Now another bigger unit of time, that is year. 365 days make 1 year. 1 year is the, here is the definition of 1 year. 1 year is the time taken by the earth to complete one revolution around the sun. So we can write as 1 year is equal to 365 days. How many seconds? 365 into 86,400 seconds. That is equal to 3.15 into 10 raised to 7 seconds. So these units can be summarized below like this. Okay. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. That is equal to 3,600 seconds. 1 day is equal to 24 hours, that is 86,400 seconds. 1 year is equal to 365 days, that is equal to 3.15 into 10 raised to 7 seconds. Okay, students, our next topic is devices for measuring time. So it's a time to wind up our class. I hope you all understood the topics. So today we are going to wind up the class. Goodbye and have a nice day.